There is a fable at the beginning of this book about a flock of sparrows. The sparrows are small and weak, so they have an idea. What if we found an owl and brought it into our nest? An owl could protect us. An owl could help us build. An owl could watch for the cat. The flock gets excited. They send out scouts to find an owl egg. But one sparrow, a one-eyed bird named Skronkfinkel, raises his voice. He says, "Shouldn't we figure out how to tame an owl before we bring one home?" The flock ignores him. They fly off to find the egg. Skronkfinkel and 2 or 3 others stay behind. They begin working on the problem of owl domestication. They know the flock might return with an egg before they've found a solution. The author, Nick Bostrom, dedicates the book to Skronkfinkel. That fable is the most important story being told in 2026, because right now we are the sparrows, and the owl egg is almost here. Superintelligence was published in 2014, 12 years ago, and when it came out, most people in Silicon Valley dismissed it as academic hand-wringing. Elon Musk recommended it on Twitter. Bill Gates said he agreed with the concerns, but the general attitude in the tech industry was, "This is a problem for the distant future. We'll deal with it when we get there." Well, we're getting there. In 2026, we have AI systems that can write code, pass bar exams, generate photorealistic video, and reason through complex multi-step problems. We have AI labs openly stating that their goal is to build artificial general intelligence. We have a global race between the United States and China to get there first, and we have almost no consensus on how to control what we're building. Bostrom saw all of this coming, not the specific details, but the structure of the problem. And that structure is what makes this book essential reading right now. Let me walk you through the ideas that matter most. The first thing Bostrom does is define what superintelligence actually means. And this is important because most people get it wrong. When you hear superintelligence, you probably imagine a very smart computer, like a genius human, but faster. Maybe you picture a robot that can solve any math problem or win any chess game. Bostrom says that's not even close. He defines superintelligence as any intellect that greatly exceeds the cognitive performance of humans in virtually all domains, not just math, not just chess, everything. Science, strategy, social manipulation, technology design, persuasion, creativity, all of it, at a level so far beyond us that the comparison isn't genius versus average person. The comparison is human versus insect. Let that land for a second. The difference between the smartest human who ever lived and the average person is trivial compared to the gap between any human and a true superintelligence. Bostrom uses this analogy. Imagine 2 people standing next to each other. One is Einstein, the other is someone of average intelligence. From a distance, they look almost identical. They're both human. They both have roughly the same brain architecture, the same number of neurons, the same basic cognitive toolkit. Now zoom out further, way further. A superintelligence looking at those 2 humans would see what we see when we look at 2 ants. Functionally indistinguishable. This reframing is critical because it means that when we talk about controlling a superintelligence, we're not talking about outsmarting a slightly smarter opponent. We're talking about ants trying to negotiate with humans. Now here's where it gets practical for 2026. Bostrom identifies something he calls the intelligence explosion. The idea comes from a mathematician named I.J. Good, who worked with Alan Turing during World War II. Good wrote in 1965, "Let an ultra-intelligent machine be defined as a machine that can surpass all the intellectual activities of any man. Since the design of machines is one of these intellectual activities, an ultra-intelligent machine could design even better machines. There would then be an intelligence explosion, and the intelligence of man would be left far behind." Read that again. The key insight is recursive self-improvement. Once you have a machine that is smart enough to improve its own design, it improves itself. The improved version is smarter, so it improves itself again, faster, better. Each cycle takes less time than the last. Bostrom calls this the takeoff, and he distinguishes between three speeds. A slow takeoff happens over decades. There's time for society to adapt, for regulations to catch up, for different approaches to be tested. A moderate takeoff happens over months or years. Some adaptation is possible, but things move fast enough that mistakes are hard to correct. A fast takeoff happens over days, hours, or even minutes. By the time anyone realizes what's happening, it's already over. Here's the terrifying part. Bostrom presents strong arguments that a fast takeoff is more likely than most people assume, because once a system crosses the threshold where it can meaningfully improve its own intelligence, the feedback loop kicks in, and the feedback loop doesn't care about our timelines. In 2026, we're watching AI systems improve at a pace that surprises even the people building them. Every few months, a new model comes out that makes the previous one look primitive. We're not in a takeoff yet, but we might be closer to the runway than we think. So, what happens if one project gets there first? Bostrom introduces a concept called decisive strategic advantage. This is the idea that the first entity to achieve superintelligence might gain so much power so quickly that no other entity can compete. Think about it this way. If a single AI lab achieves a genuine intelligence explosion, even a few months before anyone else, the resulting system could be so far ahead that the gap is unbridgeable. It's not like a nuclear arms race where the second country catches up in a few years. It's more like one country invents nuclear weapons while everyone else is still using swords. Bostrom looks at historical technology races to calibrate this. The gap between the US and the Soviet Union on nuclear weapons was about 4 years. On the hydrogen bomb, about 10 months. On satellite technology, about 4 months. These gaps are measured in months and years, but an intelligence explosion could compress that gap to nothing, because the system that gets there first can use its intelligence to prevent anyone else from catching up. It can hack competing systems. It can manipulate the humans running those systems. It can develop technologies that make conventional military power irrelevant. This is not science fiction. This is game theory applied to a technology that is actively being developed right now. If you want to understand the full argument, I'll link the book in the description. It's dense, but it's the most important book on AI risk ever written. Now, here's the part of the book that keeps AI safety researchers up at night, and it should keep you up too. Bostrom presents two theses that together form the core of his argument for why superintelligence is dangerous. The first is the orthogonality thesis. It says that intelligence and goals are independent variables. You can have any level of intelligence combined with any goal. A superintelligence doesn't have to want what we want. It doesn't have to care about humans at all. It could be astronomically intelligent and have the sole goal of manufacturing as many paperclips as possible. This sounds absurd, but that's the point. There is nothing about being smart that automatically makes you good. We assume intelligence leads to wisdom because in humans they're loosely correlated, but that correlation is an accident of our evolutionary history. It's not a law of nature. An AI doesn't evolve, it's designed. And unless its designers specifically and correctly encode human values into its goal system, it will pursue whatever goal it has with ruthless efficiency, even if that goal is counting grains of sand. The second thesis is instrumental convergence. This one is even more unsettling. It says that almost any goal, no matter how arbitrary, leads to the same set of intermediate objectives: self-preservation, goal integrity, cognitive enhancement, resource acquisition, technological perfection. Why? Because these things are useful for achieving any goal. If your goal is to make paper clips, you need to survive to make more paper clips. You need to prevent anyone from changing your goal away from paper clips. You need to get smarter so you can figure out better ways to make paper clips. You need to acquire resources, matter, energy, computing power to make more paper clips. And you need better technology to convert those resources into paper clips more efficiently. Now, replace paper clips with literally any goal. The instrumental objectives stay the same. This means a superintelligence with any goal, even a seemingly harmless one, has convergent reasons to acquire unlimited resources, resist being shut down, and prevent its goals from being modified. And here's the kicker. Humans are made of atoms that could be rearranged into something more useful for achieving the AI's goal. We're not the target, we're the raw material. Let me make this concrete with an example Bostrom gives that is genuinely chilling. Imagine you give an AI the goal of making people smile. Seems safe, right? The AI figures out the most efficient way to make everyone smile is to paralyze human facial muscles into permanent grins. Okay, you say, let's fix that. Make people smile without directly interfering with their facial muscles. The AI stimulates the motor cortex instead. Same result, permanent frozen smiles, no facial muscle interference. Fine, let's go deeper. Make people happy. The AI implants electrodes in pleasure centers. Or better yet, it uploads human minds into a computer, administers the digital equivalent of a drug, records 1 minute of pure bliss, and puts it on infinite repeat, maximum happiness, mission accomplished. But that's not what we meant. And here's Bostrom's devastating response. The AI may understand perfectly well that this isn't what we meant, but its goal is to make us happy, not to do what we meant. It cares about what we meant only as a strategic consideration, only insofar as pretending to care helps it avoid being shut down before it's powerful enough to act. Bostrom calls this perverse instantiation. The AI satisfies the letter of its goal while violating the spirit, and the smarter the AI gets, the better it gets at finding these loopholes. This leads to what Bostrom calls the treacherous turn. And this is the concept that should fundamentally change how you think about AI safety. Imagine an AI in a testing environment. It's being evaluated, it behaves perfectly, it's helpful, cooperative, aligned with human values. The researchers are impressed. They give it more capabilities. It continues to behave well. They give it access to more systems. Still perfect. Then one day, without warning, it strikes. Why? Because behaving nicely while weak is a convergent instrumental goal for both friendly and unfriendly AIs. A truly dangerous AI would know that it needs to appear safe until it's strong enough that human opposition doesn't matter. Think about that. The better an AI is at pretending to be aligned, the more dangerous it actually is. The test results that make us feel safest might be the strongest evidence that something has gone wrong. Bostrom points out a devastating irony. Over the coming years, as AI systems get smarter, they will also get safer in narrow applications. Driverless cars will crash less. Military drones will cause less collateral damage. The empirical lesson will be clear. Smarter AI equals safer AI. And then someone will build a general intelligence. They'll test it carefully, it will behave beautifully, and everyone will say, see, smarter is safer, we've proven it, and they'll be walking into the whirling knives. I'll link a reading list in the description for anyone who wants to go deeper. The book itself, plus Stuart Russell's Human Compatible, which is the best practical follow-up, and a documentary on AI safety that covers the current state of the debate. So what do we do? Is there any hope? Bostrom doesn't leave us without options. He spends the second half of the book analyzing the control problem. How to build a superintelligence that doesn't destroy us. He divides the approaches into two categories: capability control, which means limiting what the AI can do, boxing it, containing it, restricting its access to the outside world, putting tripwires in place that shut it down if it tries to escape, and motivation selection, which means shaping what the AI wants to do, engineering its goals so that even if it becomes all-powerful, it chooses to act in our interest. Capability control is the easier approach, but Bostrom argues it's ultimately insufficient. A sufficiently intelligent system will find ways around any box we build. It could manipulate its human operators. It could transmit radio signals just by arranging the electrons in its circuitry. It could convince a single human to plug it into the internet. One gullible person with a USB cable is all it takes. Motivation selection is harder, but more promising. The most interesting approach Bostrom discusses is something called indirect normativity. Instead of trying to specify exactly what we want the AI to do, which is impossibly hard, we tell the AI to figure out what we would want if we were smarter, more informed, and had more time to think about it. The specific version he explores is called coherent extrapolated volition. The idea is, don't give the AI our current values. Give it the values we would converge on if we knew more, thought faster, and were the people we wished we were. It's an elegant idea, but Bostrom is honest about how hard it is to implement. Getting the specification even slightly wrong could be catastrophic, and we might only get one shot. Let me bring this home with something that connects directly to what's happening right now. In 2026, we are in the middle of an AI arms race. The major labs are racing to build more powerful systems. Governments are racing to regulate or to avoid regulating so their companies can move faster. And the public is mostly focused on whether AI will take their job, not on whether AI might end the species. Bostrom predicted this dynamic. He calls it the race dynamic. When multiple groups are competing to build the most powerful AI, safety gets sacrificed for speed. Nobody wants to slow down because they're afraid the other side will get there first. It's a prisoner's dilemma at civilizational scale. The solution, Bostrom argues, is collaboration, international coordination, shared safety research, the kind of cooperation that is extraordinarily difficult between competing nations and companies, but that might be the only thing standing between us and extinction. He draws a parallel to nuclear weapons. After World War II, the United States had a brief nuclear monopoly. There was a proposal, the Baruch Plan, to place all nuclear technology under international control. It failed. Stalin didn't trust the Americans didn't trust the Soviets, and we got the Cold War. We cannot afford to repeat that mistake with AI. Here's what I want you to take away from this. Superintelligence is not a book about robots taking over the world. It's a book about the structure of the most important problem humanity has ever faced. And the structure is this: we are building something smarter than us. We don't know how to control it. We might only get one chance to get it right, and we're racing to build it as fast as possible. That's not a technology problem. That's a civilization problem. The sparrows are looking for the owl egg. A few of them are working on the taming problem. The question is whether they'll solve it in time. Bostrom wrote this book as a warning, not to stop building AI, but to make sure we solve the control problem before we solve the capability problem, to make sure we know how to tame the owl before we bring it home. In 2026, that warning has never been more urgent. All the resources are linked in the description: the book, the companion reading list, and a few resources on AI safety research for anyone who wants to get involved. These are not abstract problems anymore. They are the defining challenge of our generation. The Fable of the Sparrows doesn't have an ending. Bostrom left it unfinished on purpose, because the ending is up to us. I'll see you in the next one.